So let's see if yeah, it's doing it correctly now. So R of x equals f of g of h of x. And we are given that h of 1 is 2, g of 2 is 3, h prime of 1 is 4, g prime of 2 is 5, f prime of 3 is 6, and we're asked to find r prime of 1. And then we can continue to the next section. So like before, last time we said, okay, how can I determine r prime of 1 if I don't have r prime of x? So first I have to find r prime of x, which is 1, 2, 3 functions. F prime of g of h of x times g prime of h of x times h prime of x. So the chain rule does not have addition or subtraction unless it's a product or a quotient. So this is a simple f of g of h. So normally this is written f comp g comp h of x. So f of g of h of x. From this moment on, everything is clear. I just have to determine step by step. So f prime of g h of 1. So this should be 1. So h of 1 is 2. Times g prime of h of 1. h of 1 is 2. Times h prime of 1. h prime of 1 is 4. I continue. G of 2. G of 2 is 3. So then I have f prime of 3 times g prime of 2 is 5 times 4. Finally, f prime of 3 is 6 times 5 times 4. I prefer to multiply these to get 20 and multiply by 6 to get 120. Any questions for me? Are we okay with what we looked at? One thing I would like to go back to, we know that e to the x prime is e to the x. I should write times x prime the inner function, but there is no need. But what happens if I have any base, not e, any base prime? So this should be times x prime and also times natural log e, but also this is 1. This is 1, so that's why we didn't write them. But when we differentiate a to x prime, we get a to x times x prime, which is 1, times natural log a. So if we have e to the x, we should multiply by natural log e, just to remember this formula basically. But here there is no need because it's 1. This is 1, of course. A to the x prime is a to the x times natural log a. And maybe we should look at an example like that, so we practice that. So we can make one up if I can find one. Oh yeah, that looks a little bit more involving, but that's okay. So let's look at y equals 2 raised to power 3, that is raised to power x squared. Okay, so let's see how we address this. Where's my prop? Where's my prop? Here it is. So I have to differentiate y, which is 2 raised to a function. So 2 raised to a function. So when I differentiate 2 raised to a function, I have 2 raised to that function multiplied by the function prime and multiply by natural log 2. So 2 raised to a function prime is 2 raised to the function times the function prime times natural log 2. And now I will uncover, and instead of the function, I will write what I have here. So 2 raised to 3 raised to x squared, this is this piece, multiplied by, let's put it in parentheses for now, 3 raised to x squared, leave it alone, but it has to be prime eventually, times natural log 2. And now we continue from here, here. This is done, and now I have 3 to a function prime. Instead of 2, I have 3. Fine. So 3 to the function prime will be 3 to the function times the function prime times natural log 3. I will copy the first piece. I can copy natural log 2. And now I have 3 to the function. I will uncover 3 to the function times the function prime times natural log 3. Yes, it needs to be rearranged a little bit, but that's it. So I can group these two because this is 2 to a power multiplied by 2 to the first power. So I could write 2 to whatever plus 1, or not. But it would be nice to do that. So I will write 2 raised to 3x squared plus 1, this and this. Then I will put the x. Then I will copy 3 to x squared. And then I have to copy these two constants. Natural log 2 times natural log 3. This was a lot of work because of 3 raised to x squared. So that was slightly more involving. Any questions? Any questions for me? How do we feel about this? How do we feel about the chain rule? Any questions about the chain rule? No questions? Anyone?
What's the prime of 3 to the x squared?
3 to the x squared will be 3 to the x squared times 3x times x squared times 2x times natural log 3.
Okay.
So maybe I should write here again. So 3 to a function prime is 3 to that function times the function prime times natural log 3. So now I will plug in here x squared. So this is x squared. And this will be 2x. Is that better?
Yep. That's good.
So 3 to x squared, then times 2x, and then times natural log 3 is the same rule. But this time it has 3 as the base instead of 2.
Okay, thanks.
Thank you. Other questions? Anyone? Anything else? Okay, 3.5 deals with implicit differentiation. Implicit differentiation. When I'm given the function like I was, let's say f of x equals 3x squared minus 2x plus 5, the function is given directly. Function is given directly. I'm given the function and I'm asked to find the derivative. But I may be given an equation that I cannot solve to determine the function. For example, let's say I have, e to the y times sine x equals x plus xy. Here we are asked to find not y, No. Find dy over dx, or if you want, y prime. We will not be using, you're more than welcome to, but we will not be using this notation when we use implicit differentiation. Okay. Is it wrong? No. It's not wrong. But it has some drawbacks. And I'll explain, I'll tell you when. If you try to solve this equation for y, I will wish you good luck. Only computer softwares can do it. We cannot. We have no way of determining y as a function of x. There is no way anyone can solve this equation by hand. Okay, so I cannot solve for y. I don't have y directly. Y is given to me indirectly in an equation. It is given to me, but I can't solve for y. Can I find the derivative, an expression for the derivative of y? I can. It will have y in it, but I still can't determine an expression for the derivative. How do I do it? By differentiating both sides. I'm differentiating both sides. So I differentiate the left-hand side, and I differentiate the right-hand side. Before we do that, we have to establish, when we are asked to find dy over dx, what does this mean? What does this tell us? Can anyone say anything? I'm going to mute you. So you can unmute yourselves when you want to talk. So, what does this mean? A few minutes ago, maybe an hour ago, this question was brilliant because it helps me now. So, when a point on a function is negative 2, 4, we immediately understand that f of negative 2 is 4, and immediately understand that f of 2 is negative 2. This is mandatory. Once we are told that these points are on the graph of the function, they have to verify the equation. So f of negative 2 must equal 4, otherwise the point will not be on the function, and f of 2 must equal negative 2, otherwise the point will not be on the function. So now, when I am told to find dy over dx, what am I told here is this. Treat y as a function, not variable, of x. This is clearly understood. You must treat y as a function of x, not a variable. I am really told that y is a function, I'm writing it again to be clear, of x. So, when I differentiate the left-hand side, this is the first function and this is the second because this is a product. This is whatever, just a variable, no problem. But this is function 1 and this is function 2. Not the same, of course. By 1, 2, I mean in a product. The first function, the second function. 1, 2. So let's see how we get an expression for y from all that. When I differentiate e to a function, it's not e to the function. It's e to the function times the function prime. So then we write e to y times dy over dx. This is just this piece differentiated, multiplied by sine x plus e to y times sine x prime is just cosine x. I'm on the other side now with the equal symbol. X prime is just 1 plus, I have to apply the product rule again. X prime is 1 times y plus x multiplied by the second function prime, which I don't have, so I have to write it as dy over dx. from all this is my variable. This is what I'm solving for. I want this term next to the other with the same variable, and I want this term without the variable on the other side. So this entire term moves to the left-hand side. This entire term moves to the right-hand side. Of course, I change the sign when I do that. So the left-hand side is e to the y times sine x times the variable, and then minus x times the variable equals 1 plus y minus e to the y cosine x. 1 second, and I will write it here. So that's my page 11. Yes, yes. Okay, so e to y sine x minus, I'm sorry, dy over dx minus x dy over dx equals 1 plus y minus e to y cosine x. This is the variable. I will have to factor it out because I cannot combine like terms. So e to y sine x minus x dy over dx equals 1 plus y minus e to the y cosine x. And yes, in order to determine this, I have to divide by what multiplies it. So dy over dx equals whatever over whatever. Although I don't have the function, I determine an expression for its derivative. Yes, it does have y in it, because I cannot extract it from there. I cannot solve for y. Why is this helpful? I don't have the function. You could say, but you don't even have the derivative because you don't have the function. True, but I can evaluate it. If you give me x equals and y equals, I can give you a number for the derivative, which is the rate of change of the function at that point, which is the instantaneous velocity if it's a distance, which is known even if I don't have the function, or per se I don't have the derivative. But I can give you the slope of the tangent line and the rate of change at that point, as long as you give me a point. But of course the point has to verify the equation. Otherwise it's not a point on the equation. So this is what we call implicit differentiation. And we can look at an example in which we are given a point, and we can determine even the equation of the tangent line to the graph of a function that we don't even have. So let's look at sine x plus y equals 2x minus 2y at the point pi comma pi. We can solve this for y. So we're asked to find the equation of the line, of the tangent line. Find the equation of the tangent line to the graph at pi comma pi. So I know it's y minus y1 equals the slope times x minus x1. That's no problem there. That's easy. This is pi and this is pi, but I don't have this, which is the slope.